Somebody for you, sir?
All right, good morning. Hey, you need to have your textbook and you need to go and find the lesson 261. Um, the page that I have here is not correct. It's going to be somewhere in the hundreds, I'm not even sure, 170-ish. I don't know. No idea. But what you're going to do is you're going to flip through your book and you want to find lesson 261, and that's what we're going to do today. We're going to be working through that lesson, a few examples, and then you're going to do the homework that follows the third and the fourth example. Okay, so what I'd like you to do right now is go through this warm-up, and I want you to just try to identify what the change in altitude or her rate of change in her altitude during a 5-second interval would be. All right, so Cecilia took her first parachute jump lesson last week. Her instructor gave her a graph below that shows her change in altitude in 5-second intervals. So that means that her x values, all right, or her time is going to be showed every 1 second, but she showed in a 5-second interval. So it stopped here, but clearly she's going to continue descending to the ground. So what I want you to do is I want you to go through, pause the video, and I want you to answer these questions, all right, 1, 2, and 3, and then play the video and then see if your answers match. All right, so here are your answers for the warm-up. So as we look, for every 1 second, for this descending from an airplane, you can see Cecilia starts at 2,700 feet. That's where she's starting, and that's what her y-intercept is. It's her starting point. So she's jumping out of the plane and she's descending at a constant rate, or what we'll identify as a constant rate by finding our rate of change, also known as our slope. So if you look here, I just counted down and over. So we went down from 2,700 to 2,400, so it's negative 300, and then over 1 second, which gave us this rise over run, or our slope of negative 300 meters for every 1 second. All right, now, if you're like, I'm not sure if that's it, well, you could check some other points here. As you see, I used the slope formula, all right, y2 minus y1 over x2 minus x1, or if you wanted to do y1 minus y2 over x1 minus x2, you get the same answer. But I took 2 different points. I took our starting point, all right, and then I also took a different point that was in here. I took 3, 1800. So after 3 seconds, she is already at 1800 feet above the ground. And when I simplified, I got negative 300, and it really should be over 1. So if you look from any 2 different sets of time, all right, so from the 0 to the 1st second, or from the 0 to the 3rd second, we're still declining or descending to Earth at the same rate of change, which means that our function in a couple things are going to tell you that, number 1, your graph is linear. If you didn't know that already, it's linear because we have a constant rate of change. And 2, we can identify our rate of change by her altitude is decreasing by 300 meters every second, or per 1 second. All right. Now, just a review from what we did on the quiz and then what we did on the previous test is domain and range, just practicing that. So our domain is from 0 to 9. Now you might be saying, why is it 9? Why isn't it infinity? Well, if you kept looking, all right, if you kept looking and calculating what the slope would be, all right, if you're going 3,000, if you're descending 3,000 meters or 300 meters every 1 second, and if you went a total of 2,700, if you went 2,700 divided by 300, meaning, all right, if we're dropping 300 feet or meters every 1 second, it would take 9 seconds for you to land onto the ground, all right, at that same speed, all right? So that's why it has to be 9 here, all right? It's not going to be infinity. Infinity means that you would plummet into the center of the Earth and keep going down, and you'd end up on the other side of the planet, but that's not how it is, all right? So at 9 seconds, that's when it is. And then our range, clearly we land on the ground at 0, and we start 2,700 feet above the ground, okay? So that's a good one. So if you did put infinity, again, we really want to start thinking, hey, in reality, when will he hit the ground? And that's one that you can just evaluate or think about And hopefully that helped you out there too. You would just take your total height, all right, which is 2,700, and divide by 300 meters, and you figured out your total of 9 seconds. 9 seconds is when this graph would hit the ground. It would hit at 9, all right? And that's what your range would be. It would be from 0 to 9, or excuse me, your domain. All right, so what we're going to do is we're going to go through a couple examples, and today what we're going to be doing is we're going to be comparing functions, all right? We're going to compare different functions and different properties. So today, as you flip the page, if you were like, hey, where's page 291? These pages are not right. Just keep flipping the page, and we're going to do example 1, all right? And today's lesson is rather simple because you've learned all these properties. You've learned about rate of change, and you've learned about y-intercepts, but today what we're going to do is we are going to compare. And compare means is to identify a difference or similarity. Now, not many of these functions will have similarities. Now, you could say, oh, they're both linear, they're both exponential or whatnot. But what we're trying to do is we're trying to identify more so which one is greater or less than the other. All right, and that's really what we're looking for today, is we're going to determine which properties of which functions are greater or less than the other. So the properties today, the two properties that we're going to be comparing are rate of change, ROC, all right, also known as slope. All right, that's one of them. And your second property that you're going to compare is your y-intercept, also known as your starting point. Okay, so those are the two that we're going to compare. So it says the functions f of x and g of x are described below. Compare the properties of each. So we want to compare the rate of change, and we want to compare the y-intercept. So in order to compare, you actually have to find each property, rate of change and slope, for each one before you can start comparing. So what we'll do is we're going to start with f of x. And f of x I'm going to do over here on the left side in green. All right. So f of x, let's start with the rate of change, aka slope. So our rate of change, if you look here, we could do a couple things. We could take 2 points and calculate the slope. But what I'm going to do is, since I have a graph, I'm going to choose 2 points, all right, and any 2 points. So I'm just going to pick a couple points and show you a couple points here, all right, and we're going to calculate the rate of change by counting rise over run. So I'm going to start at this first point. Always start from the left and move your way to the right, and I'm going to count my slope. From this point to the next point, I went down 2, so that's -2 over 1. So right now, my rate of change is -2 over 1. But I'm just going to check it a couple more times. So from this point to this point, I went down 2 over 1. Oh, that's -2 over 1. Let me check it one more time. Down 2 over 1. Hey, that's a constant rate of change, which means that that should be a line, which is what it looks like. Now, another thing you could do, all right, let me erase this so we can kind of get a better vision of what's going on here, is let's say you didn't choose these 2 points that are right next to each other. Let's say you're like, you know what, I want to find the rate of change between this point and this point. So from here down here, it would be down, excuse me, I think it's down 8, because this is 8. So down 8 over 4, and -8 over 4 equals -2 over 1. So it's always going to give you back to the same simplified slope. So you might as well, when counting your slope on a graph, you might as well just look at the 2 points that are closest together to identify your slope. All right, it's just easiest and saves you some time having to simplify. All right, so I'm going to clear off this a little bit. So our rate of change is 2 over 1. Let's erase some of this. All right, and let me draw this back on here. So there are 2 things that you are trying to identify to compare. So rate of change, check, we did that, and then your y-intercept. Now our y-intercept here on our graph is where it crosses the y-axis. So our y-intercept right here is going to be 0, 8. And we had that was our first point that we had looked at. So now what we're going to do is we're going to take a look at the, what is this? This guy, the table right here, and we're going to calculate rate of change and slope. All right. So the first thing is your rate of change. So let's take a look at that rate of change. Oh, now here's the deal. The rate of change you can't actually calculate like by counting rise over run. You're actually going to have to do your slope formula. So our rate of change is going to equal big division bar minus minus. All right, so I'm going to choose any 2 points. I'm going to choose this one and this one. These are 2 coordinates. So I'm going to take my y values and I'm going to put them in -10 over minus -8. And remember, we already put the minus sign, so it's minus minus. And then the x values, -2 minus -1. Now we got a bunch of negatives, so we got to be careful with what our answer is going to be simplified. So -10 minus -8. Well, minus minus turns to plus. So it's -10 plus 8, which is -2, over -2 minus -1. So minus minus turns to plus. -2 plus 1 is -1. So now, -2 over -1 can be simplified to +2 over 1, also known as 2 over 1. It's hard to see, sorry, 2 over 1. So, look at that. All right, so this is going to have a positive slope. Now the second thing we need to compare is the y-intercept. Well, the y-intercept, I can't see what a y-intercept is because there's no graph, but if we remember about the properties of y-intercepts, they always have an x value of 0. So what we're going to do is we're going to look at our table and find where x is 0, right there. So it's 0, -6. So now what we're going to do is, since we've identified the 2 things we're going to compare, rates of change and y-intercepts, you're always going to compare those 2. All right. We're now going to determine which has a greater rate of change. Now, all right, if you look, all right, identify the rate of change for the first function, f of x. That was -2 over 1. Identify the rate of change for the second function, +2 over 1. Identify the y-intercept. Well, we got that one. That was 0, 8. Identify the y-intercept of the second function. That was 0, -6. And then compare. So now what we're going to compare is which one has a greater rate of change. Now notice how I wrote that out, greater rate of change. Well, technically, these both are the same rate of change. And you might be saying, no, they're not. One's negative, one's positive. But they're both losing or gaining 2 values. So technically, they have the same ROC, but one is +2 and the other is -2. So it's the same. When you're comparing rates of change, you're kind of looking for which one has the most amount of change. Well, they're both having change. They're both having 2 values of change. One is increasing by 2. The other is decreasing. Now, this next one's a little bit easier. Which one has a greater y-intercept? Well, this y-intercept's +8. This one's -6. So what we would say is f of x has a greater, not ROC, excuse me, y-intercept of 0, 8. And I always like explaining what my y-intercept is and which one is bigger. And clearly, 8 is larger than -6. And that's what we're doing today. We're going to compare these 2. So in order to compare, you first have to be able to find them. And then once you find them, now you have to determine which one is greater. And this one, I like starting with this one, is it's actually the same. And some kids freak out. They're like, no way, it's not the same. It is. -2 and +2, when you're talking about rates of change, they're really the same. One's positive, one's negative, but one's not greater than the other. All right. So let's try example 2. So flip the page. Again, we're not on 292. We're just on the next page. All right, doing example 2. So example 2 says, all right, your employer has offered 2 pay scales for you to choose from. The first option receives a base salary of $250 plus 15% of any merchandise you sell. We've done a problem like that before. All right, that's called commission. All right, and then the second option is the graph. So it's this thing. All right here. So compare the properties. So we're going to compare the ROC of both and the y-intercept. All right. Now, in order to do this, if you look, you're like, all right, Mr. Quammen, I can do rate of change super quick and y-intercept super quick for this first function, for the second option. All right. So why don't we do that? How about ROC? Let's figure that out first. So what I'm going to do, find 2 points. So I'm going to start here. Ooh, look at that. This is actually a special point, 0 to 100. That's actually your y-intercept. So why don't we just write that down also? Our y-intercept is 0 to 100. All right, but now we need another point. So we want to look for a point that's on the crosshairs, and right there looks like a good one. So to count, I'm going to rise now from 200 to 300. So we're going to rise 100 and run. Now this is what you're going to have to look at. We start at 0 and we're running 500. So my rise is 100 over 500, which is going to equal 1 over 5. You see that? So my rate of change for this one is up 100 over 500, which means your weekly salary will increase by $100 if you sell $500 of merchandise. All right. So we got our rate of change and our y-intercept, which means you start with your salary at $200. Your starting salary is $200. So now, the second function, we're actually going to need to write the equation out. So it's y equals. Now, many students are going to think, hey, it's percent. It's going to be a exponential function. It is not. All right. This 0.5%, or excuse me, 15%. First off, you have to write it as a decimal, 0.15. And this is your slope. This is what your money is going to increase by. Is going to increase by 15% of the merchandise you sell. So it's another similar graph, right? But your slope is going to be 0.15. So it's going to be y equals 0.15x plus your b, your starting value, which is 250. So from here, our rate of change, aka slope, is 0.15 over 1. Now, some of you might be like, hold on, I don't even get that. I don't even know what that means. Well, we'll talk about that in a second. And then our y-intercept is, all right, 0, 250. All right. Now, clearly right now you can compare the y-intercepts and say, hey, you know, technically the first option, all right, has a larger y-intercept. This is the second option, which is the graph, right? Clearly the y-intercept here is greater. But the rate of change is kind of tough because this is not written the same way. You see how this is a fraction, 1 over 5, and this is 0.15 over 1, because you want to write it always as your rate of change as a slope. So what I'm going to do is I'm going to actually leave this the same, all right? And what I'm going to do is I'm going to convert 1/5 as a decimal. So 1/5 as a decimal is 0.20, and then I'm going to put it over 1. And this is how I'm going to compare my rates of change here. All right, it's a lot easier when your denominator is the same. They're both 1. Now all you have to do is compare your numerator. So 0.15 and 0.20. This rate of change is greater. This is a greater ROC. Greater. My handwriting is terrible, and of course on the computer it's even worse. Greater ROC. This is a greater y-intercept. So what we'll do is at the bottom, we're going to compare. So the first option, okay, which is over here, has a greater y-intercept. A greater y-intercept of 0 to 50. All right, and that's your starting amount. So you're starting with more money. But the second option, I'll just put a number, second option has a larger ROC of 0.20 over 1, which in theory means, all right, if you're like, well, what does that mean? It means you earn 0.20, which is 20 cents for every $1 you sell. Whereas the other one, you were earning 15 cents for every dollar you sell. So that's what we're doing. We're learning and really just working on comparing to hopefully in our future make some smart decisions with money, investments, so that we choose the right fund to put our money in. All right, this is what we're going to do. We're going to do one more problem. Oop, no burn break. We're going to do one more problem, and it's not on page 293. It's just example 3. This is going to be our last one before we do our homework. So what I want you to do is I want you to try this one on your own, pause it, and then start the video up and see if you get the same answer, okay? Cool. All right, so let's see. So we have 2 airplanes, all right? Function, this first function, f of x, all right, is an equation, all right? And the second airplane is the graph, all right, is our graph here. So for the first function, I love when it's written in the equation. So our first function, or you could call it f of x, because I think the other one is technically called g of x. But anyway, so our first function, our rate of change is your slope, and our slope is 400. So our rate of change is 400, or I'm going to put it 400 over 1, which, all right, is rise, which means 400 meters for every 1 minute, which is always important to know your units. And then our y-intercept, so our y-intercept is going to be 0, 1,200. So that's the information from the first function. Now the second function, all right, your rate of change, you're going to actually have to calculate that. So here, if you notice, the y-intercept is a little tough to find. So we're going to have to give a good approximation here. It's going to be 0, and I think I'd go 5, 7, 5, 0. That would be a good one. You're like, oh, 5, 8, 5, 0. Okay, cool. But I would wait on that. I think this is going to be the best one, because to calculate the ROC, what I'm going to do is I'm actually going to choose nice points. So 550, and then this is another nice point, which is 5,000. So I'm going to go down 500, because from 550 to 5,000 is 500, over, and then if you look, it's from 1 to 3, it's 2 minutes. So 2. So our ROC is going to be negative 500 over 2, which will simplify to negative 250 over 1. So that's going to be your rate of change. So it's going to be meters over minutes. All right. Now, if we were to actually backtrack it to go up and over, it would be going up 250 and over 1, which is why I know for sure this is 0, 575 and not 5,800 or 5,751. All right. By using our slope and reversing it up, you're going to just take 550 and add 2,000 or 250 to it, and that's how you get your y-intercept. So our y-intercept is 0, 5, 7, 5, 0. So anyway, all right, we have a rate of change for our first function and our y-intercept. We have a rate of change for our second function and our y-intercept. So let's compare. Now, quickly comparing them while we're looking at them, all right? The rate of change 400 over 1 and negative 250 over 1. This is greater. So your first function has a greater rate of change. This one is greater. All right. This one also is increasing. So this is actually like a plane going up. This one's a plane going down. All right. But it's a greater number. All right. When you're comparing rates of change, it doesn't really matter about positives and negatives. You just care about which number is actually bigger, which one has the most change between a single interval. And that one, increasing by 400, is greater than the decreasing by 250. Now, a little sidebar. If this were technically, let's say, negative 500 over 1, this would actually be the greatest rate of change. Because even though it's negative, your change is 500 rather than 400. But that's not how the problem is. So anyway, this has a greater rate of change. Greater ROC is over here. And then the second one is y-intercepts. Well, this y-intercept is 1,200. This one's 5,750. This is a greater y-intercept. You see that? So what we're going to say is function 1 has a greater ROC. Function 2 has a greater y-intercept. All right, so with that done, what we're going to do right now is we are going to start your homework. Now, this is what your homework is going to be. all right? You need to flip. It's not going to be these pages. Again, the book, these are page numbers from the old book. Your new book is literally, it's just going to follow. It's like the next page that follows it, but you're going to do 1 through 10, all right? And this is what it looks like. It's not 297, all right? This is not it, but it's 261 and it's practice. So you're going to do 1 through 10, 1 through 10. So this is the first one. It looks like this, function A, function B. Now notice, I'm going to show you this. This table for function A for this first one is a little funky, all right? Notice they do not fill in all the numbers. So I would encourage you to make your own table that has -4, -3, so see this, -2. See how it doesn't have those values here? So use these values, all right, and go from -4 to 3 so you can help find your slope. If you take a look, what's happening is from -4, it's 12, and then you're missing some values. You go to 0, -12, -6. So what's happening is our slope is actually going down by 4. So that's what's happening as we go down by 4, down by 4, down by 4. So to fill the gaps, we're going to reverse the slope and we're going to add 4. So -12 plus 4 is -8. -8 plus 4 is -4. -4 plus 4 is, 0. Look at that. All right. So you're just going to keep going. Add 4. So it'll be 4. Add 4. And this will be 8. And if you were to check your slope, all right, you should be subtracting 4 going downward. 12 minus 4 is 8. And these are your y values for this table, but you had to fill in the table to make it, okay? So from here, function A, function B, you're going to compare, like we did for our examples, the rate of change and the y-intercept, and you're going to do that for everyone, all right? Make sure you check the answers in the back of the book, and we'll go over this on Monday. All right, thank you. Have a great weekend.